thermal resistance. What should be the definition of thermal resistance? For that we can draw the diagram, a rectangular slab. This is a rectangular slab. This is a rectangular slab. This is a rectangular slab. Which has the temperature theta 1 degree C, and this face has the temperature theta 2 degree C. And here what we can write, theta 1 greater than theta 2. And area of cross section of this face is A, and this face is obviously cold face, and other face, left end, is hot face. This is what we know as cold face of the slab, and other face is the hot face. This face, left face or left end face is the hot face. Thickness of the slab is x. Thickness of the slab is x. Thermal conductivity is denoted by K. Heat energy will be conducted from left end to right end, because theta 1 is greater than theta 2. Rate of conduction of heat is Q by T. And this is what rate of conduction of heat, Q by T. What we can write, the rate of conduction of heat, rate of conduction of heat through rate of conduction of heat through a rectangular slab, is given by Q by T is equal Ka theta 1 minus theta 2 divided by x. Theta 1 minus theta 2 divided by x. Where theta 1 minus theta 2 is the difference in temperature, of the two faces of the slab, comma, theta 1 minus theta 2 divided by x is the temperature gradient, rate of change in temperature with respect to the thickness of the slab, that is temperature gradient. And what about K? K is the coefficient of thermal conductivity. Coefficient of thermal conductivity of the slab. Coefficient of thermal conductivity of the slab. Therefore, Q by T can be written as what? Difference in temperature divided by something. Theta 1 minus theta 2 divided by X by Ka. The previous expression was Q by T equal Ka theta 1 minus theta 2 divided by X, and this can be written as theta 1 minus theta 2 whole divided by X by Ka, whole divided by X by Ka. And this is equation 2. This is equation 2. Equation 2. And this is actually rate of conduction of heat. This is actually rate of conduction of heat. Again, we can repeat, this is the rate of conduction of heat. And this expression, this is analogous. This is analogous to Ohm's law. Which is given below. Which is given below. That is I is equal to difference in potential difference by resistance. I is equal to V by R. V by R. And this is what? This is the electric current through what? This is the electric current through an electric resistance R, through an electric resistance, through an electric resistance capital R. Now here we can compare this with what? Q by T is the rate of conduction of heat. It is the rate of conduction of heat. Conduction of heat. And I is the electric current or rate of conduction of charge. Is the electric current. That is the rate of conduction of charge. Rate of conduction of charge. Conduction of charge. Charge is small q. Theta 1 minus theta 2 is the difference in temperature. Theta 1 minus theta 2 is the difference in temperature. of the two faces of the thermal slab. Difference in temperature. And here V is the potential difference across an electric resistance, potential difference. And if we draw the diagram, a diagram analogous to rate of conduction of heat through a rectangular slab, this is an electric resistance R. And we can denote the potential difference. V is the potential difference across this electric resistance R. In that case, a current I will be flowing from left end to right end. And I is the current which is a rate of conduction of electric charge. So in this case, what we can compare, that means electric resistance R will be equivalent to X by Ka. X by Ka. Therefore, the quantity R is equal to X by Ka is called the thermal resistance. Thermal resistance against the rate of against the conduction of heat, comma, in analogy to the electric resistance, analogy to the electrical resistance capital R. Greater the, here we can conclude again, that is greater the thermal resistance, greater the thermal resistance, comma, poorer will be the thermal conduction. Same as that fact that greater the electric resistance, poorer will be the electric current through the electric resistor. Poorer will be the thermal conduction. And what about the unit of thermal resistance? Unit of thermal resistance will be what? We know that R is equal to X by Ka. What will be the unit of thermal resistance? We know that Q by T is equal to theta 1 minus theta 2 divided by thermal resistance. Hence, from that, R has another expression, that is R will be equal to theta 1 minus theta 2 divided by Q by T. Theta 1 minus theta 2 has the unit Kelvin. So Kelvin second per joule. Kelvin second per joule, that is the unit of thermal resistance, Kelvin second per joule.